If we are live or not. Takes about 10 seconds or so. Yeah, we have the link. Start in a second. Okay, let's see if we have the sound. Is anything working today? Some of the streams are just, you start a stream and nothing works. What is it? Murphy's Law? Okay, seem to have the correct microphone. So I won't be monitoring my own sound because I don't like my own voice. I know if I don't unplug any USBs or anything, the microphones and camera keep working okay, so I don't have to keep monitoring. That being said, let's monitor it. Okay, just check. Okay. So still this fuzzy logic tool. It might be a long one as well, like the music out of EEG. Took about 20 live streams. So it will be over 20 hours or so of development, and probably more. I try not to do things offline, but sometimes it's very tempting. It's also a lot of the time you finish a stream that nothing worked and you try something and it just starts working after you stopped recording. So that happens as well. Hopefully today it will actually happen during the recording. So we have that fuzzy logic tool. Can select a waveform type. Yeah, later we'll try to have a scroller that just scrolls through them, and those values change as you scroll. They do change when you adjust the input parameters at the moment. Now we discovered that originally the bot suggested something that was wrong. So now we're trying to fix it. So yeah, there was a misunderstanding. It was calculating, it was giving an array of extracted features. So essentially, for each data point, this input waveform will have a value for symmetry and sharpness, which is not correct. We need it for the whole waveform. So now it suggests that we should correct the code. However, I tried something new where, so GPT-4 has a lot of the context. You can load all the code into it and it doesn't forget it. Keeps Copilot seems to forget what was just happened a couple seconds ago. So what we're doing right here is when the original GPT generated the code, we also asked to generate prompts for the changes in the last response. And Let's start a new GPT, because yeah, that was it was going places there. It was wrong. So we're now replacing calculate peak, sharpness array, and symmetry array into one value. So for example, we already took it from GPT, but just so it has the context, let's quickly do this again. It should essentially produce the same code. Calculate waveform symmetry. To assess the symmetry, it's dividing the whole waveform into two parts. There's the first half, second half. Yeah, it makes more sense than left and right. This is really good. Yeah, this is actually much better. Because there will be a problem if there's an odd number of data points. That should not be the case. It should be always 100. Sec. There should always be 100, so maybe that is not necessary. Symmetry, that's calculating symmetry. All right, it's gonna make more sense in the original code if the numbers of dot points is not even, it just returns symmetry equals 0, because yeah, that can make sense, because if it's, because that means that the signal is not symmetrical. Then the symmetry itself, absolute value, yeah, it's a different calculation. So the original one is calculating the mean. Arithmetic mean, and the second one is would be a problem after this. Yes, those. Yeah, how about we just calculate symmetry? Should not be an array. Calculate sharpness. Remove the waveform from there. Okay, now it's better. Calculate sharpness. So expected to work. Getting an error sign, will we? Yes. Fuzzy data is missing or invalid. Okay. Yeah, probably need to do that. Let's get a new one. Calculate sharpness. I'll also add the prompt to modify fuzzy logic function to use the new whole waveform symmetry and sharpness features. Now, yeah, this will give us a wrong output, but we'll try it anyway. Already have fine peaks, fine troughs. I don't know why it's starting to regenerate the whole thing. To update the membership function. Okay, can GPT-4 do this as well? Because Copilot for whatever reason tried to update the whole code. I don't know why. Let's add more membership functions. It's a bit odd. Now the membership function is going from 0 to 10 instead of 0 to 1. Let's read that quickly.
To update your fuzzy underscore logic function in a way that it uses the overall symmetry and sharpness of the entire waveform to make classification decisions, you need to modify how the function interprets these features and how it applies the fuzzy rules based on them. Here's a step-by-step guide to do this. Update feature inputs. Change the inputs to the fuzzy underscore logic functions so that it receives the overall symmetry and sharpness values of the entire waveform instead of arrays representing these features at each point. Revise membership functions. Redefine the membership functions for symmetry and sharpness to reflect their new, holistic interpretations. For example, the range and shape of these functions might change to accommodate the new range of values that the overall symmetry and sharpness can have. Modify fuzzy rules. Adjust the fuzzy rules to make decisions based on the overall characteristics of the waveform.
The thing is, those rules, the membership function, the 0 to 10 should correspond to the range of outputs for symmetry and sharpness. I think that is correct. What is the range of output for symmetry and sharpness calculations? says it doesn't have access to the specific data or calculations. There is no data that should be in the code. Range output standard channel calculation depends on the specific methods, blah blah. I was expecting something more specific. Okay, I'm not having much luck with Copilot.
Adjust the fuzzy rules to make decisions based on the overall characteristics of the waveform. The logic of these rules might change significantly because you're now dealing with a global assessment of the waveform rather than point-by-point analysis. Based on the outputs of these rules, implement the logic to classify the waveform into categories like square, triangle, trapezoid, etc. This will likely involve aggregating the rule outputs and using a defuzzification method to make a final decision. Choose an appropriate defuzzification method, like centroid, bisector, etc., to convert the fuzzy outputs into a single crisp output, which will be your waveform classification. After implementing these changes, test the fuzzy underscore logic function with various waveforms to see how well it classifies them. Based on the results, you might need to further adjust the membership functions, rule definitions, or the classification logic.
That's actually suggesting to simplify the code to have only symmetry low and high, sharpness low and high. We have the rule. It's not the complete code, obviously. Can you look at the code above and regenerate the whole fuzzy logic function? That. Why did it change the input? Symmetry universe. Now it's back to 3 levels: low, medium, high. The membership function is between 0 and 1. They are trapezoid. That's what I have in the code, isn't it? Yes. Okay, now just copy pasting from my code, from the earlier code. I have another rule for unknown. Let's sharpness. Go ahead and It's as if it's forgot about that unknown, or did I add it later? Must have added it later. Okay, we're getting stuck.
Certainly. Here are prompts for implementing the changes suggested in the last response. Prompt for adjusting symmetry calculation. Update the calculate_waveform_symmetry function to assess the symmetry of the entire waveform. This function should take the entire signal as input, split it in half, and compare the two halves. Calculate the symmetry as the average difference between corresponding points in the two halves. Also, include handling for waveforms with an odd number of points. Prompt for adjusting sharpness calculation. Create a new function calculate_waveform_sharpness to measure the overall sharpness of the waveform. This function should identify peaks and troughs in the waveform and calculate sharpness based on the average absolute difference between these peaks and troughs. Implement helper functions find_peaks and find_troughs to detect these features in the waveform. Prompt for modifying fuzzy logic function. Modify the fuzzy_logic function to use the new whole waveform symmetry and sharpness features. Update the membership functions and fuzzy rules to classify the waveform based on its overall characteristics. Ensure that the fuzzy logic system can now make decisions about the group or type of the entire waveform based on these updated features. Prompt for implementing peak and trough detection. Develop find_peaks and find_troughs functions to detect peaks and troughs in the waveform. These functions should analyze the signal to find local maxima and minima, which will be used in the sharpness calculation. Ensure these functions are robust to noise and can accurately identify significant peaks and troughs. Prompt for handling odd-length waveforms in symmetry calculation. In the calculate_waveform_symmetry function, add a specific condition to handle waveforms with an odd number of data points. Decide on a strategy for handling the middle point in fuzzy logic function. To modify the fuzzy_logic function in your code to use the new whole waveform symmetry and sharpness features, and to update the membership functions and fuzzy rules accordingly, follow these steps. Update membership functions. Redefine your membership functions to reflect the global characteristics of symmetry and sharpness for the entire waveform. This might involve adjusting the ranges and shapes of the membership functions to better suit the global features. Redefine fuzzy rules. Change the fuzzy rules to make decisions based on the overall waveform characteristics. The rules should now consider the global symmetry and sharpness to classify the waveform. Modify fuzzy_logic function. Incorporate these changes into your fuzzy_logic function. This involves using the new symmetry and sharpness calculations and applying the updated membership functions and rules.
Code looks more like it. I like this one. So let's modify the function step by step. So we're already calculating global features. Don't need to prove it's actually called. Don't have the waveform in the name. That's okay. They do take in the noisy signal. Where did it getting this information from? It is the noisy signal. This is the noisy signal. Okay. Symmetry. I like what we have so far, but now the membership functions. So suggesting 2 low and high. I have 3 low, medium, high. Let's stick to the low, medium, high. Same. So those are the membership functions. Then you have a degree of membership. just sharpness. That's the fuzzy interpolation, symmetry universe. Okay, that looks legit. Then we have the fuzzy rules. So we have suggesting to have type A. It's type A. So square has low symmetry, low sharpness. Triangle has low symmetry, high sharpness. Okay, there's a problem there. That's because we're not using the medium stuff. Pretty sure we would need 3 levels, but and then this code is not complete because the rule types.
This updated _fuzzy underscore logic function now analyzes the entire waveform using the global symmetry and sharpness features, applies the redefined membership functions and rules, and then classifies the waveform into a specific type based on the aggregated fuzzy logic output. Remember, the specific membership functions, fuzzy rules, and mapping of defuzzified output to waveform types depend on the characteristics of your waveforms and the types you want to classify. You may need to experiment with different configurations of these elements to achieve accurate and meaningful classifications.
A couple of issues. First of all, wouldn't 3 levels be better than 2? So for symmetry and sharpness, have membership functions of low, medium, and high instead of low and high alone. Second issue, can you look at the code that I provided and update the rule names? There should be rule square, rule triangle, and rule trapezoid. A third problem is we need to include an option where the algorithm doesn't know what the waveform is and producing a unknown as an answer. Yep. Didn't get unknown. It's a good idea. Okay. Updating rule names. Yes. Handling unknown.
An unknown classification can be handled by setting up a condition that if none of the rules are sufficiently activated, the algorithm defaults to an unknown output.
That sounds good. Why is it? Okay. It's using triangular membership functions again. Okay, the rule square, symmetry high. Yeah, that's incorrect. I don't know what happened there. It was producing, yeah, this says Python. Then all of a sudden it's CSS. What? But it's the continuation. Some threshold. It's that threshold. To define a threshold for unknown. We need to return the centroid as well. Ah,
Membership functions are updated to include 3 levels: low, medium, and high. Fuzzy rules are renamed and adjusted to classify waveforms as square, triangle, or trapezoid based on the overall symmetry and sharpness. An unknown classification is introduced for cases where the maximum activation of the rules is below a certain threshold, indicating that the algorithm is unsure about the waveform classification. You should define _some_threshold based on your specific requirements and experimentation. This threshold determines the confidence level below which the algorithm decides that the waveform does not sufficiently match any of the defined types.
couple of issues with it, but yeah, we have trouble integrating. Degree of membership. We have the rules. Okay, let's go over the rules again. Square. Yes, symmetry should be high. Sharpness low. Or medium. and triangle sharpness high. Symmetry low. Depends which triangle we're talking about. Currently getting a 500 response. Okay, sharpness high. Trapezoid. Okay, rule square. What are those? Okay, I think we don't need that. That's adding zeros to make the length to match length of arrays. What's the difference between these two? Yeah, let's go with the more recent one. Where's the defuzzify? Let's do this here. I'll keep it centroid. It's meant to be. Do I have single quotes or double quotes? Yeah, there's still a problem. Yeah, we need to watch just the JavaScript as well. being used. What's the problem? It's a noisy signal instead of signal, isn't it? Something I don't get in Copilot. Go JavaScript. How to modify this JavaScript code based on recent changes in the Python server backend. So does it actually? Need to modify the JavaScript to work with this Python code. Are you kidding me? This is the Python backend. What? Don't understand. So that's okay. The shit is hopeless. Can you see the above JavaScript code that I provided earlier? Based on the changes, the recent changes in Python code, do we need to modify anything in the JavaScript as well? Yep. Yeah, Copilot is hopeless with context.
Update the function that displays the output of the fuzzy logic, update output, to handle the unknown classification. Ensure that the front end can display information about the medium membership levels for symmetry and sharpness. Modify the function plot fuzzy logic parameters to include the visualization of the new medium membership functions for both symmetry and sharpness.
I already have it.
Adjust the plotting logic in plot fuzzy logic parameters to display the activations of the new rules, rule_square, rule_triangle, and rule_trapezoid. If these are still relevant, ensure that the logic for calculating and displaying detection error and unknown percentage is updated to reflect the new, unknown, classification.
Yeah, it's all the same. The fuzzy data is now called something else. It's doing these funny things now, where it's generating another response with how to win. What? Yeah, nothing works.
Your Flask application seems to be structured for analyzing signals, adding noise, and using fuzzy logic to classify the signal type. The code includes various routes and helper functions. Renders the home page. Analyze, accepts post requests to analyze signal data. It generates a signal, adds noise, analyzes the signal using fuzzy logic, and calculates detection error and unknown percentage. Generate underscore signal, input underscore wave, generates different types of waveforms based on input. Add underscore noise, signal, noise underscore amplitude, adds noise to the signal. Analyze underscore signal, noisy underscore signal, analyzes the noisy signal using fuzzy logic. Fuzzy underscore logic, noisy underscore signal, applies fuzzy logic to classify the signal. Calculate underscore symmetry, signal, calculates the symmetry of the signal. The errors you're encountering in the console suggest issues with data retrieval or parsing from your server's response. Here are the key points related to your errors and some potential solutions. Centroid and fuzzy data undefined. The centroid, undefined and fuzzy data, undefined errors indicate that these properties are not present in the response data object. Ensure that the server correctly includes centroid and fuzzy data in the JSON response. Debug by logging the entire data object received from the server, console.log, data, to see if these properties are actually being sent. Noisy signal data missing or invalid. This error suggests that the noisy signal property is either not present in the response, or it's not in the expected array format. Verify the server-side logic that adds noisy signal to the response. Check if the noisy signal property exists in the response and if it's formatted as an array. Detection error and unknown percentage history data issues. The error messages error, detection error history or unknown percentage history data is missing or invalid indicates similar issues for detection error history and unknown percentage history properties. Confirm that these arrays are included in the server response and that they're in the correct format. Possible causes and debugging steps. Server-side issues. The Flask server might not be processing the request correctly or might not be including the expected properties in the response. Review the server code to ensure that all necessary data is computed and included in the response. Request payload issues. Make sure the request payload, input wave value and noise amplitude value, is correctly formatted and sent to the server. Network issues. There might be a network issue preventing the request from reaching the server or the response from coming back. Check the Network tab in your browser's developer tools to inspect the request and response. Asynchronous timing issues. Ensure that your JavaScript logic correctly waits for the server's response before attempting to access properties on the data object. As a general debugging tip, use console.log statements in both your server-side Python code and your client-side JavaScript code to trace the flow of data and identify where the breakdown is occurring. The error message, length of X and fuzzy membership function must be identical, indicates a mismatch in the lengths of the arrays being used in your fuzzy logic calculations on the server side. This issue is causing the server to fail in generating the expected response, leading to undefined values for centroid, fuzzy data, and noisy signal in your JavaScript console. Here's how you can address it. Check membership function array lengths. In your Python server code, ensure that the arrays used for X coordinates and membership function values, mf_**, have the same length. This is crucial for the fuzzy logic functions to work correctly. The lengths of symmetry_universe, peak_sharpness_universe, and the membership functions like mf_symmetry_low, mf_symmetry_mid, etc., should match. Debug fuzzy logic function. Add print statements or use a debugger to inspect the lengths of the relevant arrays, symmetry_universe, mf_symmetry_low, etc., in the fuzzy_logic function. This will help you identify where the length mismatch is occurring. Adjust array generation logic. If you find that the lengths are not equal, adjust your code to ensure that they are. This might involve changing how you generate these arrays or how you calculate the membership functions. Error handling. Improve error handling in your Flask app. When an exception occurs, make sure to log detailed error information. This will help in diagnosing issues more effectively. Client-side error handling. On the JavaScript side, enhance error handling to gracefully handle cases where the server response contains an error message. This could involve displaying a user-friendly message or handling missing data more elegantly. Test with different inputs. Once you fix the issue, test your server with various inputs to ensure the problem is resolved and that your fuzzy logic functions are working as expected. Remember, the key to resolving this issue is ensuring that all arrays used in your fuzzy logic calculations have the same length. This is a common requirement in fuzzy logic libraries to perform operations on corresponding elements of these arrays. The line, noisy signal, noisy_signal. Tallest, in your Flask application is intended to convert the NumPy array noisy_signal into a list before sending it as part of a JSON response. JSON responses cannot directly handle NumPy array formats, so this conversion is necessary. However, the error you are encountering seems unrelated to this line. If you are still receiving errors like, length of X and fuzzy membership function must be identical, it indicates an issue in the fuzzy logic processing part of your server-side code, not in the conversion of noisy_signal to a list. The problem lies in the way you are defining or using the membership functions and their corresponding x-axis values in the fuzzy logic calculations. To troubleshoot this, verify lengths of arrays. Ensure that the arrays for the x-axis, symmetry_universe, peak_sharpness_universe, and the arrays for the membership functions, mf_symmetry_low, mf_symmetry_mid, etc., have the same length. This is crucial for fuzzy logic calculations. Debug fuzzy logic function. Your fuzzy_logic function looks well structured for processing the noisy signal using fuzzy logic. It calculates symmetry and sharpness features, defines membership functions, computes rule activations, aggregates these activations, and then uses defuzzification to determine the output wave type. It also prepares data for plotting. However, the error you encountered earlier, length of X and fuzzy membership function must be identical, suggests there may be an issue in how the membership functions or their activations are being calculated. To troubleshoot, consider the following steps. Verify membership function lengths. Ensure that the arrays mf_symmetry_low, mf_symmetry_mid, mf_symmetry_high, mf_sharpness_low, mf_sharpness_mid, and mf_sharpness_high have the same length as Check symmetry and sharpness calculations. The variables symmetry and sharpness should be scalar values representing the respective features of the noisy signal. Ensure that these values are being calculated correctly in the calculate_symmetry and calculate_sharpness functions. Inspect rule activations. The NP, FMIN functions used in calculating rule_square, rule_triangle, and rule_trapezoid should work correctly as long as symmetry_* and sharpness_* values are scalar and within the range of the corresponding membership functions. Double-check these calculations. Inspect rule activations. The NP, FMIN functions used in calculating rule_square, rule_triangle, and rule_trapezoid should work correctly as long as symmetry_* and sharpness_* values are scalar and within the range of the corresponding membership functions. Double-check these calculations. Defuzzification. The call to fuzz. Defuzz uses the aggregated array and symmetry_universe to calculate the centroid. Ensure that aggregated is correctly formed and has the same length as symmetry_universe. Output decision logic. The logic for deciding output_wave based on the centroid value seems reasonable. However, ensure that the thresholds 0.2, 0.4, 0.6 align well with the expected output types. Logging for debugging. Add more print statements or logging throughout this function to track the values of key variables and identify where the issue might be occurring. Remember, the most critical aspect is to ensure that all arrays used in fuzzy logic calculations, for membership functions, activations, and aggregation, are correctly aligned in terms of their lengths and values. By carefully checking each step and ensuring that the data aligns correctly, you should be able to resolve the error. Based on the output you shared, it seems there is an issue with how the fuzzy logic membership functions are being applied or interpreted. Let's break down the information. Symmetry value. The calculated symmetry is 0.9460389751007992. This is a scalar value representing the symmetry of your noisy signal. Membership function mf_symmetry_low. The membership function array mf_symmetry_low shows decreasing values from 1 to 0. It's designed to represent the degree to which the symmetry value is considered low. However, the function should ideally start with 0, peak at the range where symmetry is considered low, and then decrease back to 0. Symmetry low activation symmetry_low. The symmetry_low activation is 0.0. This makes sense given the high symmetry value, which falls outside the low range of the mf_symmetry_low membership function. Rule square activation rule_square. The rule_square is calculated as 0.076866820126199914. This is derived from the fuzzy logic rule, which likely involves a combination of symmetry_high and sharpness_mid, or similar. From this output, it appears that the mf_symmetry_low membership function may not be correctly defined for your use case. Given that symmetry is high, you would expect low membership in the low category, which is what you see. However, the shape of MF_symmetry_low is unusual, as it starts at 1 and decreases, which is not typical for a fuzzy membership function. Consider the following adjustments. Redefine membership functions. Membership functions should reflect the fuzzy categorization of your input variables. For example, a low symmetry membership function should peak where symmetry values are considered low and taper off as values move away from this range. It's unusual for a membership function like MF_symmetry_low to start at 1 and then decrease. Review membership function definitions. Ensure that the parameters defining the trapezoidal membership functions, fuzz, trap_MF, correctly reflect the ranges you intend for low, mid, and high categories. The 4 parameters define the feet and shoulders of the trapezoid. For a low function, you might expect it to start and end at 0, peaking in the low range. Check all membership functions. Review the definitions for all your membership functions to ensure they accurately represent the intended fuzzy logic. Consider visualization for debugging. Visualizing these membership functions can greatly aid in understanding and debugging them. You might plot these functions to see their shapes and adjust as necessary. By carefully revising the line symmetry_universe equals NP, linspace 0, 1, len, noisy_signal, is creating a numpy array named symmetry_universe that ranges from 0 to 1, with as many elements as the length of noisy_signal. However, using the length of noisy_signal to define the universe for the symmetry this array is intended to represent the However, using the length of noisy_signal to define the universe for the symmetry variable might not be appropriate, depending on the context of your application. The length of noisy_signal could be quite large, especially if it's a time series data, and it's not necessarily related to the range of values that symmetry variable can take. Appropriate range for symmetry. The symmetry, in most contexts, would be a value between 0 and 1, where 0 represents complete asymmetry and 1 represents perfect symmetry. The universe of discourse for this variable should reflect this range. In your case, NP, linspace 0, 1, 100, or similar might be more appropriate if you want to define 100 discrete points within this range. Consistency with membership functions. The universe of discourse should be consistent with the ranges used in your membership functions. If symmetry_universe has a different range or number of points than expected by your membership functions, it can lead to errors or unexpected behavior. Simplification for debugging. If you're debugging your fuzzy logic system, you might want to simplify things. Start with a smaller, more manageable universe of discourse until you're sure everything works as expected. Then, you can scale it up if necessary. Reviewing the context, ensure that the way you're using symmetry_universe makes sense in the context of your application. If symmetry is a feature calculated from noisy_signal and is meant to have a range between 0 and 1, then the approach should be fine. However, if symmetry is not directly related to the length of noisy_signal, reconsider the logic behind using len, noisy_signal, to define its universe. In summary, make sure that the definition of symmetry_universe aligns with the expected range and usage of the symmetry variable in your fuzzy logic system. It seems like you want to continue working on the fuzzy_logic function for your signal processing application. Given the information and context from your previous queries, here are some key aspects to focus on while you refine this function. This function will use fuzzy logic to analyze the signal, involving steps like calculating key features, setting up membership functions, defining rules, and applying defuzzification. Here's a structured approach to rebuilding the function.
Happened to ChatGPT, it's producing the code as text outside the Python window, and then another window called bash, which doesn't make any sense. It's having these super bold letters. Yeah, something is up. It's going down. It's the CEO out the company again. It will go down at some stage. Okay, we got another 10 minutes or so. Let's go quickly over some questions and stuff. Someone's suggesting to stream on Twitch. Well, yeah, good luck with that, because from OBS it seemed to be impossible to stream into two different platforms, so you have to use another tool. So it becomes rather complicated. And I have to stick to YouTube because I'm trying to get monetized. Well, the project is, for it to be sustainable. There was another comment that I can't find. Frederick was asking, do you have a video on denoising a channel using a different channel as noise reference? So I did have videos on denoising channels, but not using a different channel as noise reference. I don't know why we should do it in EEG, considering you don't know which one is essentially don't necessarily know which channels should be used as reference. It can be tricky to know. The solution likely involved adaptive filtering. Yeah, we've done adaptive filterings as well. It's some noise reduction. Noise reduction. Make window size small. You can see what the difference is. This noise reduction is wavelet based. You can select your wavelet type. Someone was using dB5. You can probably add it. Yeah, I'm doing up to 4. There's normally in this particular data set there's bugger all. Difference. Though some of them reduce more noise than others. some other channels it's the noise reduction is more pronounced. If you do detrending, actually overlaid. Yeah, it's a bit buggy, this thing. Filter order doesn't change much. Don't expect that to change anything. Yeah, I'll be more than happy to revisit this tool, make improvements on it. So if you have any more specific suggestions, they're more than welcome. Shall we end with some music? So we haven't published that tool yet. Actually haven't. We normally deploy Fridays. We develop Monday to Thursday, deploy Fridays. That tool is currently a bit different in the sense that it's only client side. It's only client side. The camera is being used, so that won't work. Start a video source. Okay, that won't work. Can we remove the camera from the stream? Stuffed something up, didn't it? Let's try this again. Anyway, the previous videos of me using it, so nothing really works today. Nothing in the chat. No one wants to interact. That makes me sad. So I'll see you next time. Bye.